Hi everyone. So in this part of the video, we'll be talking about operations on one-dimensional array. We've already seen two operations on one-dimensional array, that is insertion and deletion, in the previous video. In this part of the video, we'll be only talking about the searching mechanisms in a one-dimensional array. Now when we talk about a searching mechanism, any data structure array in any programming language has two searching mechanisms. One being the linear search and the second one being the binary search. So let's just learn what is the difference between a linear search and a binary search. Now when we talk about linear search, a linear search can be applied to any array, sorted or unsorted. But when we term binary search mechanism can only be applied to arrays which are sorted. And let me tell you one thing, binary search is much faster than linear search. Now why is binary search faster than linear search? As I explain the mechanism, it will be clear to you. So let me start with the linear search. Okay, linear search, what does this mean? Let me just diagrammatically show you. Suppose this is your one-dimensional array. Okay. And you have some elements in it, let's say 2, 6, 1, 5, 9, 4, and you want to check if number 9 exists here. Okay, now to search for something in a list, we already know that we already have inbuilt functions in a list. Okay, but we are learning here the algorithms or the mechanisms that work with an array of any programming language as such. Suppose I'm searching for 9. What is a method of linear search? You start from the first index location and you go up till the last index location. So that means what is the index location in an array beginning from 0? Okay, you start from 0. Is this 9? No, go ahead. Is this 9? No, go ahead. Is this 9? No, go ahead. So you similarly go through each and every element of your array and search if that is the number that you're searching for. This mechanism is called linear search. Now the disadvantage here is, suppose your array is, let's say, 100 elements and your number that you're planning to search is, this is just suppose, okay, is let's say the third last element. You are still going through, or you're executing the loop 97 times to reach the third last element. So this takes times in certain situations, which can be eliminated when we learn the binary search. Is that clear? Okay, so let's just look at the lines of linear search. I'm writing it as a function. So I've written a function named as linear search, and this linear search has two parameters: the array, which is LST, and the item that I want to search. Okay, children, just note that this is indented, or you just take this outside so it gets indented. Okay, now what am I doing? I said I will loop through each index location, and that's why I've written this I loop here. I will loop through each index location and check if that is the element I'm searching for. If so, I want to know at what location did you find. I found 9 at location 4. So this is the value that is going to be returned. That is, if the element exists. If the element doesn't exist, I plan to return -1. So probably what is this function doing? This function is searching for an element in a list. If the element exists, return the location of the element, otherwise return -1. Okay, now let me show you the main part of the program, or from wherever you are going to be calling this function. To call this function, obviously, I will need to ask the user to enter the elements into the list. We've seen this part of entering the elements into the list even in the previous videos. Okay, so you ask how many elements, you go through the loop, you take one element at a time and add it to your list. After you have added it to the list, next you're going to ask is which is the number that you want to search. So I got the number that I want to search. After that, what will I do? I will call the linear search function, sending the list and the item to be searched. It will send me back the location where it found, or -1, depending upon whether it exists or no. So what is X going to be storing? Either the location where it exists, or -1 to indicate that the element doesn't exist. So I've written here, if it's not -1, what does it indicate? That the element exists, right? I said element found at location X. But if it is -1, we have learnt what is the function going to do? Return -1 only if the element does not exist. So I display a message, element not found. Is that clear? So this is the mechanism of linear search that you can use in any programming language. Mechanism, guys, the lines can change depending upon the programming style, but the mechanism or the algorithm is going to be the same. Clear? Okay, let's talk about then binary search. I just told you initially, for binary search your array has to be sorted. Ascending, descending doesn't matter, but it has to be sorted. Let's assume the number that I'm searching for is 23. Okay, in this scenario I'm searching for number 23. How does this whole mechanism work? You know what it does? It keeps dividing the arrays into halves and decides, should I be looking at the left side of the array or the right side of the array? Why? Because the elements are sorted. Once you get the middle location, once you get to the middle, you can decide whether number 23 lies to the left of the middle value or right of the middle value, or is it the middle value? Because if it is the middle value, you've already found the element. So in binary search, the element is always going to be found at the middle location. Now middle doesn't mean there is middle calculated only once. The whole big array you divided into two halves, so you got a middle. Then after you decided that your 23 lies to the left of this middle value or to the right of the middle value, and let's assume it lies to the left, then the left side of the array you will again divide into two halves. So the whole working is you divide into halves, and if that element exists, it will always be at the middle of the whatever half that we're talking about. Okay, so for that I'm going to be making use of three variables. F to indicate the first part of the array, where does the array start. L talks about the last element of my searching condition, and mid talks about the middle element. In the beginning this location is F, that means location 0, and this location is going to be L. Later on F and L will keep changing depending upon which half am I concentrating on. Okay, so let me just take you to this statement. F is at 0, why L is at 6? Because 6 is the index number of where the last element is. Programmatically you would not be writing 6 because your array could be consisting of 10 elements, 20 elements, so you'll be writing length of the list minus 1. That's how I get, because what's the length of this list? 7. 7 minus 1 is 6. Okay, then you find mid. Obviously, how do you find middle of two values? Is the first plus the last divided by 2. But here we will when you say divide by 2 in Python programming, it doesn't give me integer division because indexes are all integers, right? So we'll be using floor division, but this is just a mechanism. Okay, so what will you get here? You will get 0 plus 6 and the whole thing divided by 2, which is nothing but 3. So this is where I got mid. Let me just represent it by M. First thing you need to check, is this the number that you're searching for? So is A of mid the number that I'm searching for? In this scenario, no. Okay, so this is going to be false. Then what is the possibility? Either this number, this 35, is more than 23 or less than 23. So next condition I'm checking, is 35 more than 23? In this scenario, this is true. What does that definitely mean? I divided the array into half, right? What does it definitely mean? That there is no point looking at the right side of the array because 23 is less than 35, so it can only exist on the left side of the array. So we are not at all looking at the last part of the array. Our concentration is only on the left side of the array. If you look at the left side of the array now, you already have variable F, okay, but you don't have L. You need to bring this L to this location. Okay, so I've written L is equal to mid minus 1. What was mid's value? 3 minus 1 is 2. So your L is no more 6, it's going to be 2. Now whenever you update L, so this is my L, right? Whenever you update L, obviously now the mid is going to change, because mid is always with respect to F and L. So I calculate mid again. Okay, so I go to calculate mid once again. It says 0 plus 3 divided by 2. Now you might tell me it's 2.1, sorry 1.5, but I told you we're talking about integer division because index numbers are always integers. So I get 1. Okay, so mid is here now. What is the first thing I'm going to check? Is that the number I'm searching for? Is A of mid equal to NO? No, so it's false. Correct? Okay, if you don't want to write it and write it under this, okay, so it's false. Now, is A of mid greater than NO? What is the number at A of mid? 16. Is it greater than what I'm searching for? No. So this is also false. So then what is the next option? That it is less than NO. So if it's correct, 16 is less than NO. So what does that mean to you? Does 23 lie to the left of 16 or to the right of 16? Right of 16. So if it's right side, look, L is already there. So what do you have to update is F. F becomes mid plus 1. So this is true in this scenario. So I have to do F is equal to mid plus 1. What is mid's current value? 1. 1 plus 1 is 2. So now my F becomes 2. Okay, so F has also reached here. Okay, it's not necessary your F and L will be at the same location all the time, okay, but in this scenario, yes. Now if you update F or L, mid value changes. So what you do is find mid once again. Okay, so this is the third time I'm finding mid. So it is 1 plus 2 plus 2 divided by 2, which is 2. So now mid has also reached location 2. So this is the old value, this is the old value. Now mid has reached here. Is A of mid the number that I'm searching for? True. True means you have found the element. So how many times did I do this loop? I did this loop only 3 times. Okay. Now suppose this was now you might say even in a linear search you would have to check for 10, 16 and 23. That's because it happened to be the third element. But probably even if it was on the left hand side and it was some 7th or 8th element, within 2 or 3 searches you would have got the element. Now there is a possibility that what you're searching for doesn't exist. How do you know that in your program? Can you see F and L getting closer to each other? And maximum they can come to is at the same location. But the minute F becomes greater than L, that means if they have crossed over, it definitely means that the number that you're searching for doesn't exist. Is that clear? So is the mechanism clear? F and L, first and last location, find mid, check if that is the number that you're searching for. If it's not, either decide to go to the left side of mid or to the right side of mid. When you're going to the left side of mid, update L. Okay, L left, so L. When you're going to the right side of mid, update F. Find mid once again. And this whole procedure in a loop, we're not doing it again and again. Here I'm showing you, so I'm doing it. We write it in a loop, it will keep doing it. But how long will I loop? As long as F's value is less than L. The minute F's value becomes greater than L, you will stop the loop and you will say the element doesn't exist. Clear? Okay, so let me just take you to the lines of the function. So I have the list and I have the item. F I said first location, L I said last location. How long do I do this looping? As long as F is less than or equal to L. And how did we find mid? We said F plus L, integer division 2. Then you checked if the middle value is the number, and if it is so, you return that mid value because that's where you found the number. Then you checked if it was greater and then you updated L, or it is less, then you updated F, and this whole loop will continue. The minute you find, remember this function is going to be left, you're going to return from the function or stop. But suppose you continue the whole loop and you still did not find the element. This is the else part of the while loop, correct? The special feature of Python where it allows you to write else with for and while loop. I come to the else part and I say return -1, which means what? The number doesn't exist. Clear? Okay. Main part of the program, as usual, not going into it. Same, how do you read elements into a list? Find out from the user what he wants to search for. Call the function. The remaining few lines are just like your linear search. Call the function. If it doesn't return -1, it means it's found. Otherwise, it's not found. Is that clear? So did you understand the concept of linear search and binary search? Okay, if you were to do the program for an array which is descending order, you just need to change this sign. This you have to write less than. Clear? Is everything understood? Okay, thank you.